Hello. Okay, let me tweet out that I'm live. Right. Where are we? Here we are. All right. Tweet is out. I think people can hear me, so that's good. Let's do that. Pin this message until end of stream. Hide for myself. Yada yada. All right. Sorry. I'll start soon. Give me a moment. Okay. All right, ad break starts soon. So, while that is going on, let me just finish what I was working on before I started the stream, because I actually finished something I was about to finish. So let me just... Okay, cool. Get status. Right, we now have arena tests. Right, what do we change here? We added line numbers. Okay, that is cool. No, not dig. Even though I dig this code, that's not what I meant. Actually, I probably should zoom in. Always forget to zoom in for the stream. Let's make 18. Right, that should be readable. Jesus, I'm not used to that anymore. I haven't been streaming coding in a while, so right. You know what? How about we close? How about we close all of them? Nope, not what I meant. Okay, so I can close this. What is that? Oh, right, I was checking something here, checking something here. These I still need for a different project. And we'll get to that in a second. Okay. Base tests. What did I do there? Oh, right. Yeah, that's fine. Then, okay. Then we have main. Whoops. Get div main. Right, I removed these things, which is fine. Nope. And then finally the arena. So added tests for memory arenas and fixed some bugs as a result of those tests. Okay, we can push that. Okay, ads will probably start in a bit, so why is this so flaky? Hello? Okay, that still works. All right. Right, ad break now in progress. So I'm just going to wait that out real quick before I start explaining what I did and what I'm going to do today. All right. Whoop. Nope. Okay. GameBoy assembler. Okay, ad break ends in 16 seconds or something. Okay, cool. So I added this Dani Lib project, which is just a collection of basically things that I use to create my C applications, right? Well, it's not all of them, obviously. I just started to like pluck things out of projects that I know I kind of copied around from one project to the next. So I know it's probably good to keep them like in a separate library like this. And this is just single header library files. Well, single header, they kind of depend on each other. Like, for example, if you want to use the arena header, you kind of need the base header as well. But there's some things like so MSVC stuff. So if you want to compile without the C runtime on the Microsoft Visual Studio compiler, you can use this C file right here. Then there is this base file, which contains like all the type devs that I'm using with macros and stuff like that. Little helper things like min, max macros, all this kind of stuff. And then I have the arena, which is the memory arenas. And this is what I was working on recently because so what I did for the Dani Lib thing was to actually add tests, right? So when you now build this, it actually runs tests to verify certain things. And I just added these tests for the memory arenas essentially and found like 3 bugs that I had to fix. So that's good. But I can just show you. So if you build this project, it basically just runs a whole bunch of tests and at the moment, it's just printing out, on which line you have like a test condition, like an assert essentially, and then it shows you the code that you were trying to assert, and then it figures out whether this is true or false, right? So it displays okay or false. And there's the same for memory arenas. And yeah, it's quite useful because then if a test fails, you can kind of see the line on which it fails, so you can just jump straight into the code file and do your thing. And like, for example, I can show you if I turn this to test is false, right? So expecting this to be false, but it is true, then it will say, oh, you have like one failed test here. It shows the overall count, but okay, one failed on test arena. And there is this one right here. So this condition failed, and then we can check in line 155 while failed, right? So you then go in here and basically fix your code, right? I should know how to spell true. But yeah, this is just to sanitize things for myself. It's not like a really extensive testing suite, right? I just really quickly put this out. All it does, it records some statistics of tests, right? I have this little macros, which is like, so for example, test if is true. And all it does is it has a statement. And if it is true, right, it prints the true condition and records a successful test. But if it is not true, then it prints the error statement and records a fail test. That's all it's doing. And all of these functions, basically just increment a number, right? It's just counting how many failed, how many succeeded. And the cool thing about C macros is, like this one, you can stringify stuff that you pass in, which is essentially how I'm printing out the code of the condition that I'm currently running, which is kind of useful, I thought. So for example here, I actually check the result of virtual alloc, whether it is true, which means it shouldn't be 0. And yeah. Okay. But now these figs need to carry over to the assembler, right? Oh, and one other thing is, like, I'm about to add a header for like strings, so all my string types and stuff like that, because I've been using them for 3 projects now, so it would be good to just have them in a header with tests and stuff, but I haven't done this yet. So this is this file right here, right? The string H and string C, and I basically want to make it a single header library right here. Yeah. But what we're going to do is copy this new version of Dani Arena into the GameBoy assembler project and try to build it. So let's go into GameBoy assembler. Let's make sure we can actually build. Okay, so it still builds. Well, does it build and run? Yes, it builds and runs. Okay, I should also explain Alpha 4 released now of the GameBoy assembler. Where are we? Releases. There we are. GameBoy assembler Alpha 4. Basically, just contains all the stuff of building the syntax tree. It doesn't print out any errors whatsoever. Today I want to go more into how I'm handling error messages and then trying to pass the syntax tree to then actually generate some code. I'll go into that in a second. But first, let's copy the DaniArena.h into this project and try and make it build, because I renamed some stuff. But at least, hey, there's some bug fixes, so that's good. So open containing folder. Let's take this one. Put this in here in source, DaniLib, replace. And then we're just trying to build. Oh yeah, and if you run Alpha 4, you can see it actually builds like the syntax tree and prints it out. Maybe I didn't show this on stream before, I'm not too sure. But for example, if you look at the program GBASM, right? So what is this? Line 48. There you go. So this is LD with an indirect HLI and comma A, right? So, and then it builds you like the syntax tree of, okay, we have a list with this expression, which is an operation LD. And then the next expression is another list with an expression that is a separator, right? So this one right here, the comma. On the left-hand side of that comma, we have brackets. We have an open bracket, right? Oh, I no longer print out the brackets. Okay, whatever. This code is going to disappear anyways. That was just for debug purposes. But okay, so we have an open bracket, right? Then we have an expression within those brackets. In this case, it's a register HLI, which is correct, which is right here. And then we have a close bracket. And then on the right-hand side of the separator, we have a register, which is A, right? And then the next expression in the expression list is empty because there is nothing after this. Empty just means null, but I'm printing that as empty. And it does that for every single line of code, right? All the way down to this massive thing here, like data stuff. So line 8.3, there you go. And you have like these separators, right, which always have left, right, and then the right side has a separator again, so it kind of cascades down like this. But yeah, so that is all for 4. Anyways, okay, so we copied Dani assembler, so let's try and build. And of course we're getting errors. That's what I expected. Okay. Error C, what do we have? New memory arena. It's now just called memory arena. That's more in line with what I did before. We have the same in keyword gen. So right here. Yeah. And then probably, no need to check, here in main as well. Okay. Surprisingly, that's it. Cool. Can I... Nope. CLS. Can I still build and run? I can. Fantastic. Cool. So now we have the new library with all the fixes. That is excellent. Okay. And here I made like all the issues that were previously in a to-do are finally like tracked on this little Gitty instance that I have locally, and I prepared a milestone for Alpha 5. And you can see write binary output into the file, provide some binary functionality, binary output functionality, which I have already worked on a little bit. I'll show you in a second. And then change the global error list to something better. Now, I do want to work on this, write out binary, output binary into file, which essentially means we have to take the syntax tree, analyze the syntax tree, print out all the errors if there's any syntax errors, and if it is a valid syntax for that line, then just basically generate the code out of this, right? But for this to work and for this to stay sane, I kind of have to do this first, change the global error list into something better. And I kind of have an idea of what to do there. It's probably... Why am I pressing Control S all the time? Anyways, I kind of have an idea on how to do this, and it shouldn't take too long. Basically, what I want out of this is I don't want all the error messages. So for example, if we look in... let's go to the Lexer, right? I'm sure I'm printing some errors in the Lexer, especially when I... Oh yeah, there you go. So add source files error, right? So if I'm trying to read a hexadecimal file, I kind of have like these strings throughout the whole code, and it's kind of annoying because like if you want to change an error message, you kind of have to figure out where it is, right? So you kind of have to do a search and replace, and that's kind of hard to do. And so I thought this error list should actually have all the strings in place, right? So just a function where I just put them in, and then I just assign error numbers to every possible error. And then if that I encounter that error while parsing the file, I'm just going to say, hey, print out error number 556, for example, right? So, and then, you know, I don't have to type out the string and stuff like that. I'm not quite sure what to do about arguments yet. Yeah, that will be interesting. We'll figure it out, right? So I don't kind of want to work on that. I can show you what I've did for the binary output functionality so far. So if we go to I/O, there is the output binary, right? So, and essentially I've tried to work on something, how should I explain this? when I'm doing the code generation, I need to put it somewhere, right? I cannot write it, or rather, I do not want to write it immediately onto disk, right? I want to build the whole output file in RAM first because that is faster. And I might have to, trace back into the ROM to fix some jumps later on if we encounter some new labels and stuff like that, right? Because at some point we might refer to a label which is defined further down in the code, so you can actually produce valid code for this label and for this specific jump. So you kind of have to write some nonsense into that, remember that position, parse the whole rest of the code until you encounter the label, and then go back into the output file and fix up, the new location and stuff like that. So I kind of had to think about something like that. You could just say, okay, just have a large array and just put everything in there, right? That's fine. That's one way to do it. But also, the output buffer needs to grow, and it needs to grow in a specific way for the Game Boy assembler. So the minimum amount a ROM can have is 32 kilobytes. There is no smaller ROMs than 32 kilobytes. That's just not a thing, right? I mean, I say that there is, right? You could get away with smaller ROMs if you just stay in the upper memory address, and never address, anything that's lower than that. And I think some things like Game Genies or something like that actually do it that way. They only have very minimal code at the top, and then because they have to load the whole game ROM into it as well. But in this assembler, we're just always producing a 32 kilobyte output, right? Whether you actually have 32 kilobytes worth of code or not doesn't matter. Everything else will be zeroed out. But then you also want to be able to grow. Let's say, for example, you don't want to specify the ROM size you have beforehand, right? You don't want to commit to anything. You don't want to say, oh, I only want a 32 kilobyte ROM, right? But then as you write down your code, you realize, oh, I actually need double that space. So then you would have to go back to the beginning of the file, change the definition to 64 bits and stuff like that. All this kind of nonsense. No, I just want to grow it dynamically, essentially. So I did like this output buffer, basically, which holds onto an array of a specific length. It's just 32 kilobytes. It points to the next buffer because it won't be in sequence because there's also sections, and I get to the sections in a second. But essentially, anytime you let me show the code. Oh, I actually haven't done that yet. Yeah, I just saw the code is still commented out for growing. But essentially what you would want to do if the output is full, right, you just want to grow double in size because those are the valid Game Boy sizes. It always grows double in size. And you can verify that by looking at the GBDev. Let's go in here in the pandocs. Cartridge header. Right, you can see it here. So 32 kilobytes, then the next possible size is 64 kilobytes, then 128, 256, right, up to a megabyte, and then you grow even further. Now these are kind of outliers, and I don't know if I want to support them in the assembler. I kind of want to go from what is officially also in the Game Boy programming manual that I have right here. So I got those values actually from there, not from the GBDev website. Because I want to create an assembler that's just working according to the specs that Nintendo laid out back in the day, right? Okay, so that is that. Then I also want the ability to print out warnings and errors when you cross a bank boundary, right? So, how do I lay this out? So let's say on the Game Boy, right, a bank is 16 kilobits, right? So, so you have 16 kib, and that is a 32 kib ROM, right? Those 32 kilobytes are split in 16 kilobytes. This is usually called bank 0, which is the bank that's always in memory. And then you have bank 1, which is the one that can actually be switched out. So if you now have a bigger ROM, right, let's say you have 64 kilobytes, then what you then have is 2 additional banks, right? And you can switch those out. So instead of bank 1, you could have bank 2 in here, or you could have bank 3 in here, right? And there is an issue with, like, for example, if you, some commands can take more than 1 byte, right? So they can be 3 bytes long, for example. Now, what happens if you try to write a 3-byte instruction, and you're close to the boundary of bank 0, and 1 byte goes into bank 0, and the other 2 bytes go into bank 1, right? Well, that's kind of a problem, because when you switch out the bank, then this suddenly becomes illegal, and God knows what you're doing then, right? So that's kind of a problem. So you would want to warn against that, right? So similar, when you have certain jumps in labels, right? So while you program, you don't really, well, you kind of do know in which bank you are in. But let's say, for example, you have, in bank 3, you have a jump instruction that jumps to label foo. And your label foo is defined in bank 1. Well, that is an illegal jump. You're not possible to jump at all, because you either have bank 3 in memory or bank 1 in memory. And in order to jump to foo, you would have to switch to bank 1, in which case your jump instruction is no longer in memory. So, you know, so that is an illegal jump. So you want to warn against that, or actually print an error out for that, right? The only legal jump you could do from any of these banks, so from one upwards to however many banks there are, which there's not a real limit. At the moment, I do only support up to 8 megabytes of ROMs, and however many banks that are, divide that by 16, right? The only ever legal jump you could do is if you jump to bank 0. So, yeah, I kind of want to warn against that. And then there is specific sections in bank 0 that are reserved for, like, certain interrupts. For example, the reset sections, right? Or vblank, or timer interrupts, or joypad interrupts. And then we also have the header section, right? So I kind of have this code where, so this is the output binary. We have a total buffer size. So this is the actual buffer, the array of bytes that you have. And then I also have sections. And you can change those sections with, like, a assembler directive, for example. Let's say you want, I think they're doing that here, right? This is commented out at the moment, but this was in the example. So if you have a section called header, right, and it specifies the address of where to start in. Now, I don't want anyone to, you know, to remember these addresses and stuff like that. This is an assembler specifically for the Game Boy, right? It is designed for the Game Boy. So we can do something like, let's say we have section, and we just call this header, like so, right? We do not have to specify an address because the Game Boy assembler know where this goes into. And then whatever code you have here is then in the section header. Or let's say we have vblank, right? So every time you do a vblank, so any code that's here happens during a vblank interrupt. And same with banks, right? You could then say, well, we are actually in a bank, and we are in bank 0, 1, 2, 3, whatever, you know, like bank 99, right? So any code you have here is for bank 99. If you do not specify a section at all, then you end up in section 0, and it automatically recognizes if section 0 is full, you end up in bank 1, so you spill over, essentially, right? So anyways, I kind of had to have code for this, but like I said, it's not fully finished. This was also just the first attempt. I don't know if that makes sense like that. But yeah, here to do grow based on the additional banks that you need, right? Then here just grow double in size if you just spill over from one bank into the other or from one section into the other. One about section spill. Oh yeah, and I also keep track of every section, whether it already has been touched or not, right? So let's say you have, where's the, oh my God, there we are. Let's say you have section bank 0, right? And here you specify section bank 1. So you just do it the other way around, right? Here's your bank 1 code, and then you have your bank 0 code. And then your bank 0 code is actually so long that at one point it will switch over to bank 1. But because you've already specified and written code to bank 1, this will recognize it as well and actually warn you saying, hey, you're about to overwrite code that you've already written. So you might want to, check what you're doing there. Whether if you do not have that, it would just spill over, right? And you just get a warning that you spill over to bank 1 and then you have written into bank 1. Now, if you then switch specifically to the section of bank 1 and start to write code in, again, you would get an error message saying, hey, you're overwriting code that's already been written into bank 1, so you might want to check what you're doing there. So it's some of these things. Anyway, but like I said, I don't know if it makes sense like that or not. That's just something I came up with. And I definitely need to the growing in size and stuff. But that is not really part of, of this Alpha 5. I'm just going to focus on 32 kilobyte ROMs. I just wanted to have like some kind of structure for that. But yeah. Now, we're going to focus on error messaging for now, before we go into the parsing of the tree. I mean, I kind of do parse a little bit already. This is just the code to print out the whole syntax tree onto the terminal. But obviously, that's not what we want to do. So, okay, there will be an ad break in about 3 minutes, but I can just start on this error thing and think about a little bit how I want to structure it. Okay, I mean, one of the basic things I can start with is to specify some error types, right? So, type def enum error entry type. Let's just call this error type. Whoops. Oh my lord. Enum error type enum. Right. What do we have? Actually, maybe it doesn't really make sense to keep this as an error, right? Maybe let's do a separate file. And what it really is a message, right? So really what we want is message.h. Right. Yeah. Okay. So this becomes message type. So we have a fatal message. So that is, you know, if I report a fatal message, I kind of want to exit the process. Because like that is something that is unrecoverable, right? It doesn't make sense to continue. We're just gonna quit, bail out early. One of those situations could be in the source file, right? So when we are reading a code point and we realize that, for example, there is a truncated UTF-8 sequence, right? So that is a character that is fundamentally broken. It started out as a UTF-8 character, but then turned out to be some other gibberish. So what we then want to do is probably quit altogether, right? So at the moment I add a source file error, and then I just report this as end of file. Right? And then the tokenizer would just recognize the end of file, it would bail out to do that, but then it would still try to build a syntax tree and all this kind of stuff, which is not really, that useful. So really what I would like to have here is just say, well, just exit the process. Ad breaks are in progress. So but I'm just going to lay out the message type, so it's not really that exciting anyway. So message type, we have a normal kind of error, right? We have a warning, right? And we have a information. Do we need anything else? No, I think that is good. I mean, I kind of want to keep this the same, to be honest. Okay. Ads should be over. So I kind of want to keep this the same, right? So with message entries probably having the same stuff. It's always aligned with a file that we're processing. A line, a column, and position. And then the final message. But then we also have message ID, message code. Right, so this is what I want to use to identify messages, right? For example, like that, right? Whatever it will be. Some kind of message ID, basically. Right. I don't think it actually needs to be an enum at all. Although it's probably nicer to... I don't know. It probably doesn't need to be an enum, honestly. But then what we want is basically have add message. And what we want is the message type. And then the message code. Right? And that will then take care of actually putting everything we need into it. But then how do I report things like file name, the line, the column, you know, that sort of stuff? I mean, I could just have it like this. But then I would need to know the makeup of the messages, right? Is a message always related to a file name? Let's think about that for a second. Not really, right? Okay, and these error entries. Hey, Akakalangjo. How are you doing? So these entries, they have been stored in the memory arena as a list, right? So here you can see memory entry first, right, or the last entry, and they also always point to the next one. The reason why I did this is essentially I kept all the error messages in memory and then print them out in the end, because I didn't want parsing to slow down, because printing onto the screen, you know, takes time. Right? I wanted to parse everything first and then just print out the stuff. Can't complain? All right, good. And one of the benefits of this is you could provide then, say, some command line arguments that then say, okay, sort me, you know, sort me everything based on, you know, the message type. So, for example, put all errors first before you put all the warnings, right? Or put them as they appear in the list. Or you could say omit information or warnings and stuff like that. Mostly the sorting part. The omitting part already works, right? You just have to make a check and then not print. or you want to sort based on error codes, right? Yeah, I think I still keep it that way. Okay, let's copy and paste this over and figure out what we need, right? So this is an error entry. Well, that would become a message entry, right? Message entry, and we're pointing to the next message entry. That is fine. File name, line, column, and position. I wouldn't keep those in there. I would already format the message, right? Well, what we also need is the message type, right? And we need the message code. Again, doesn't need to be an enum, could just be an int. But I think an enum reads nicer. I'm not so sure about that, honestly, but we'll see. So then that would be our message list. Message and message. Whoops. We have the arena, the first and the last message, and we have the count. I said sorting is kind of good, right? But what if you want to sort by file name? Then I can have a different mechanism for this. I'm not going to worry about that for now. That might go way too far into what I actually want, right? Let's just keep this as close as possible to what was already there, to not disturb it too much, and just add the functionality that the message is being built in add message, and that we no longer need to provide a string of what the actual error is. We're just going to provide a message code, which will give us the error message. Okay, so void init global message list, right? And then print messages. U64 get error count. Get warning counts. Sure. Get information count. And there won't be a get fatal count because fatal messages are printed immediately because the process will exit. Okay, and then I don't know what to do with the add source file error thing. We'll figure that one out in a second. Okay, cool. So, new file. This is gonna include message. Should have named it messages. Nah, message. Okay, fine. Whoops. Nope. What am I doing? This one. Message.c. Include message.h. Right, and we need. Well, you know what? Take everything from error and just paste it in for now. Right. Like so. And we need these things. And maybe I'm gonna allow an arena to be passed in, actually. Yeah. Okay. I feel like those should go further up. They're like helpers, right? Okay, whatever. Doesn't really matter, does it? Okay, and then we... right. Include base message.c. And let's already remove error. Okay. Right, so we had a static static message list, which is fine. Then okay. Right, we created an arena here, but I'm not gonna do that in here anymore. If arena equals null, okay, we no longer need to do that. So I changed the memory arena library a tiny bit. And I actually made sure that you can have it in a way that null would never be returned, right? You will always have a valid value. And for that, I introduced like this panic macro that you can override, which will then just call a panic function, which in our case would be then just calling exit process, right? So that makes it so you don't have to always constantly check any of the returns of for the memory arenas, right? So if you allocate a new memory arena, you don't have to check whether it's 0 because, well, it won't be 0 because by that time, if it actually is 0, it will panic and close the process anyways. Same for memory arena buffer, right? If you try to get something that can't be allocated on the system for whatever reason, right? We don't know, something Windows specific, then process will be terminated. It tries to print a message out onto the screen, but who knows if that will work or not anyways. So, yeah. Actually, I should have probably done that as a separate commit. Right. So I think we did something in here. Yeah. And then we did the same in here. Yep. Okay, I'm gonna revert that real quick. Okay. What did I change in symbols? Oh, okay, that is like, okay. That's something completely else. Git commit. Added the 0.2 of Dani lit. That probably won't work. Oh, it did. Nice. Okay. And that will fail. Cool. Okay, cool. Okay, so let's not do that. That's not part of this code anyways. We're just gonna assert that this is 0, so we don't call it twice. Then we call getMemoryArenaType of errorList. Yep. And then we pass in the arena. The first item is 0, the last item is 0, and the count is 0. We probably want to have multiple counts, so we probably need arrow count, warning, oh my god, counts, and info count. Information count. I called it information everywhere, so let's just... okay, and then these things can just return that count of the global message list, so... okay. You know, I don't really have to set them to 0 because the arena is using virtual alloc, which kind of makes sure that everything is 0 anyway. So I don't really need to do that. I could explicitly do that. Maybe I should. Whatever. Okay, print errors. Okay. It's just print messages. And then later on I can maybe add something that prints like only warnings or stuff like that. But at the moment, let's just do the exact same thing. We just print all the messages. So this is doing the exact same thing, right? So it has the error list. And if the error list is 0 or the count is 0, we just return because we don't print anything. Otherwise, we get the first message, right? That will be message entry. It's message list, isn't it? Man. Okay. Message entry in the message list. Get the first message. We no longer need to do this formatting thing here. That will be done in here. So we just write the error. Hang on, this is prefix. Why prefix? Oh. I see. Okay, let's do a print message, right? And what we have is the message entry. Message. And we write the error string. Actually, no, we do a switch message type, right? And the message type is one of these. Won't be fatal. Okay, so write error string. So this is the prefix, and what we can just say is so what we have, we had file name and then this, and then we said whether it's an error or not. But maybe that should be the first thing. No, we're just gonna encode that in there. We don't even need this at all. At all. Okay, fine. Let's just call write error string, and we're just typing out the message, and then we switched to the next one while current is not null, and that just prints. Okay, cool. So now the meaty stuff will be in add error message, right? So this is what we did before. Let's see. Okay, so we're creating a new message entry. This can no longer happen again because we will panic if that happens. And then this entry has a type, which will be type. This entry has a code, which will be the code. And this entry has a message, which we need to build. Okay. Entry message. Build message, whatever that will look like, right? Okay, there's two things that need to happen. So we need to get the format, the message format string, based on the code. Then get the arguments, construct the final message, and then add message to the entry, right? Okay, so to get the format string, we can probably just have something like strt, get format string, a message code, right? And then this will just be a gigantic switch that, based on the message code that we're having, we will return, you know, something. String literal lol, whatever, right? And if it is none of those, then we should probably okay, I need to think about something here, but probably what I want to do is add the message codes. No. Let's just return an empty string. Okay, so this will contain all the format strings. So then really what we're going to do is strt format equals get format string, right, where we pass in the code. And then we kind of want to build a final message based on that. And then we probably also want a prefix, right? Because I mean, this message list is only really used when I'm starting to parse a file, right? I'm not going to use it for anything else. So having the file information on there probably makes sense. It probably makes sense. So maybe we can have ad break in progress. I'm sorry. Okay, how about I have a file info. File info doesn't make much sense. If anything, it would be a file location. Right. Also, what the hell am I writing? I don't really need to hold on to the file location, but it would make sense to pass it in, I think. Like, have it temporary. I think that's okay. And if it's not a message that's tied to a particular file, I could just leave that null. Because that information is only used when building the error message anyways. Okay, so really you want a prefix as well. I'm just wondering if an arena makes sense then, or if I should have like a buffer to construct these messages. Because I need to construct the prefix, but that only lives in memory for so long, right? And the arena is stack based, so okay. Let's hold on to like a scratch buffer. Is scratch buffer even the right name? Let's just call it message buffer. Okay. And then I just need like a little space that I can reuse to like construct the messages. If they're then too long, they're being truncated, but that's all right. So in init global message, right? Okay, we set all of this stuff, but then we want a message buffer that I can reuse, right? And that will be get memory arena buffer from the arena, and let's say we want 1 kilobyte, right? That might be too large, but we can adjust later on. You know, we could actually do this as a define. Message buffer right, 1 kilobyte message buffer length. And then we can just say message buffer length here. So we can change that later quite easily. Then we have message buffer. Do I even need the size then if I have it like this? Now let's keep it in there. Okay, message list, message buffer length. No, this length. Fine. Whatever. Okay, cool. So the get format string, right, I don't really need to do anything there. I could use the message buffer right now. That's actually a good idea. So what I would then say instead of string literal, string format. And what options do I have in string format? I do have string format buffer. Will you look at that? That's exactly what I want. So this will be the message list, message buffer, message list, message buffer length, and the format will be unknown error code. And then we just print out the error code. Right. I don't think it's unsigned. And the error code will be, what will you be? What will you be? What will you be? What will you be? Code. Yeah, okay. Okay, that will be the format string. Now we want a prefix. The prefix is going to be depending on the file location or the type, right? So let's have another one of these where we just say get message prefix, right? And that is dependent on the message type, and it is dependent on the file location. Okay, so switch type. I need to do a separate branch for fatal messages, but I'm gonna get to that. So case error, right? Let's just call this S8. I could actually just... No, that's okay. Come on. Warning. And then information. Can probably just name this info later in the output, but I'm just gonna spell it out now. So that is the type string, and the message prefix, well, so if the location is not null, then we're kind of building something, but maybe... Actually, no. This might have been overkill here. Let's just keep it empty. Let's just keep it simple. Okay, so get message type string. That is the type. Type string. Whoa. And let's call this result, right? So if we have a location, we kind of need to add the location to it. So let's build that. That will be this stuff right here. So we built the string format. This will be the global message list, a message buffer. I guess string format buffer. And then G message list message buffer length, right? And then we have the actual strings. So this will be the file name, line, column, byte. And this one right here would be the type. So this is that, right? And then we have the actual message, which is what we get later. So this would be location file name length, location file name base, actually I do have a macro for this, don't I? It's called string to format arguments. So we just need location file name. Right. Then location line, column, and position. And the last thing will be string to format args result. And really, we probably want this. Error warning information. Okay, here we could say that. No, we just leave it empty. That's fine. Leaving it empty is fine. And then we can remove this right here. Okay, so if we provide a file location, we actually build like this whole thing, and if not, we just return the result right here. So the error message will look something like this, right? Maybe I should add fatal in here. Okay, return result. This is fine. Sure. Add message. Okay, so this will be get message prefix. It's dependent on the type and the location. And then the actual message, right? So the format message. Okay, cool. So now we can construct the final message based on these things right here. So we're gonna have to get the arguments. We're getting the arguments based on the format string, but this needs to be a C string, right? I do have a little thingy here, so there we go, to C string. This will give us the argument list. Then we can call string format list and actually build the final message. Now the final message cannot reside in the message buffer that I have, because then otherwise it would be constantly overwritten, right? So this is where we then pass it into the proper arena. So the message buffer that I specified here in the beginning is just basically like a working space where you just build strings as you go along. I acknowledge there's a lot of copying going on, but it's just for error messages right now, so I don't really care. We can always work this out a bit differently to make this more performant if we want to, like directly writing into the output buffer, using something like printf instead of like, you know, and let the operating system handle it or whatever. Although, actually Windows doesn't have a call to do that. I think you always need to build the message beforehand in your own buffer, so... But yeah. Anyway, so then we can call string format list. We pass in the arena. We pass in the format. Hang on. Format list. Oh, it's a C string as well. Okay. I mean, that's okay. To C string. And those will be null terminated anyways because they're string literals right here, which are 0 terminated anyways. So that should just work out fine. It might be cool later on to, like, if you want to translate those messages, to like specify a text file that you can, you know, put next to your next to the assembly executable, and then it would just fetch the errors out of that. So you can then have translated error messages if you would like to, although I'm not sure how hard that is to do. That's for later. We're in Alpha 5, right? Who gives a shit? Okay, so we pass in the argument list right here. Then we need to call va_end, right? This will be entry message. Indeed. Okay, and then type and code here can basically just be used for sorting, right? Or if we, I don't know, maybe we want to have the ability where we're going like, okay, do not show me these warnings, right? This particular warning, because I don't care. I know what I'm doing. Then we could provide code where we're like, okay, the user has specified to not show any of these error codes right here. And then we just, whenever we encounter them while we're printing out, we can just say, okay, don't print out this one. Done, right? Okay, so this builds the prefix. This gets the format string. I'm just trying to iterate over it to see if I missed anything. Okay, this is the final message, right? And the next will just be 0. Which... okay. Prefix, format... Oh, shoot. Well, that's not quite correct, is it? This is only building the output message. Right. We haven't attached the prefix, actually. So really, oh, shoot. So get format string is fine. That is okay, but we kind of want to put that in here as well, right? So really, these two need to be combined. So instead of get message prefix, we probably want something like... Get message format. Fine, cool. Okay. Okay. Get message format, right? Let's rename this to get get message for code, right? And then this one. Okay. Get message for type. Okay, get message for code, get message for type. And then what we want to do is code message, get message for code, then T, type message, get message for type, right? Both of these should not call any formatting, right? Okay. And then okay. Okay. Right. And string to format arguments. Here we want the type message. And then the code message. Then if location is non-zero, we can attach no, we cannot because we've already built this in this buffer. Oh, for fuck's sake. Okay. Fine. Okay, that got a bit messy. Okay, so we're getting the message for the type, right, which is just the prefix, basically. And then we have the... maybe we shouldn't do it like this, because we need to combine them anyways, right? So that's not part of this message. Then we get the format string for the error code that we're trying to get the message of, right? And then we're just building the messages. So first we have the type message, right? So that will be error, for example, and then the string format that we're having right there. Okay. And then if we have a file location, however, we want to add the file information first, then the error stuff, and then just to make sure I got these right. Yeah. Okay. So basically then we have get message format for the type, for the code, and the location. And then we can get the format for the actual arguments that we want to pass in, call string format list, copy it into the actual arena, right? And then just pass in the args. So this is the actual message building. Everything else was just preamble. Okay. Cool. And then we need to add the entry to our message list. So for that, we just go message list last, right? Right. I also need to check whether I already did this down here, right? So why reinvent the wheel? So if first is 0, then first becomes our entry and last becomes our entry, right? Because it's the first message in the list. Otherwise, we go to the last message, next, and specify entry, and set the last message to our entry. Okay. And then we also need to increment counts based on the type. And of course, there needs to happen something specifically for fatal error messages, right? So we already have the scratch buffers, so that is cool. Okay, get message format, build the actual error message, and if type is fatal, print and exit process. Otherwise, we attach, right? And then increment the counts. So for that, we can just make a little you know what? Let's make an add message entry. Yeah. And let's handle all of this in there. If it's small enough, it will be inlined anyways, right? And then we can say switch entry type. If message type is fatal, well, don't really need that. Error count plus plus. Warning count plus plus. and information count plus plus. Okay. So in here, we would like to print out immediately. Now, for that, we need write output string. No, 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 no. We need write arrow string. Yeah. I mean, that's also annoying. Like, I'm building the whole... I'm building a whole entry for this, which I don't even add, which is a bit overkill, right? But I mean, who cares? We're gonna call exit process anyways, right? And what are we exiting with? I have this exit code right here, but I kind of want to have a different one. Windows exit codes, system error codes, right? Wait, there was something about... Set error mode, message beep, flash window, yeah, very important. Format message. No, that was a compiler warning. There. Bit 29 is reserved for application-defined error codes. Okay, so... bit 29. What? Okay. So anything in that range. So this actually doesn't make sense. Okay, what kind of error code do we want? Any good ideas? Wait, but how? 32-bit. That doesn't sound right. Oh, it is actually 32-bit. Okay. For some reason, I thought it was 16. But I might have mixed it up with something else. Oh, with just a word, probably. That would make sense. I mean, D word stands for double word, right? So, where is word? Do we have word? Oh my god. We have a P word, which is a pointer to a word. Word, 16-bit integer. There you go. All the way at the bottom. Okay. For some reason, I thought this was only taking 16 bits. No, it is a uint. Literally, okay. All good then. Hey, I'm working on an assembler for the Game Boy. So essentially developer tool, so you can write assembly code for Game Boy ROMs and generate Game Boy ROMs out of it. At the moment, I'm just working on the messaging system for it. So like error messages and stuff like that. Yeah, that's about it. So working on the 5th alpha version of it, where we're going to go into code generation, which I will start shortly because this seems to be actually finished. So exit process will actually not return, but it feels like I should do something like this. just, you know. But yeah, so if we have a fatal error message, we're just gonna exit the process, right? Why would you compile C without the C runtime? Well, to have less bloat in your executable, really, to have smaller executables, and because, you know, I don't like most C standard functions. It's just preference, really. And also, it's fun to learn to implement that stuff on your own. You're learning quite a lot about the platform you're working with, and at the moment I'm just Windows only. And I should do more teaching videos on YouTube. They're coming, right? I have released a few. The next few videos will actually talk about how to implement an assembler for yourself. So the next video that will be coming out is how to build Alexa. So if you want to pass any kind of file, specifically a code file in this instance, but like it could be used for anything. But yeah, it's in the works. It takes a while. Okay. Right. I think this is all right. Of course, it will now fail because we haven't used the message stuff throughout the code base, but there's also failures in message C. Okay, so let's have a look at that. Wait, C, not... Okay, what are you complaining here? Function conversion from U64 to U32, possible loss of data. Ah, right. This one right here. Strings are U32 max. Yep. Count is not a member of message list. Where do I have count? Oh, I do have count here. No. No, 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 no. Okay. Whoa. Second argument to VA start is not the last named parameter? Come again? Is there something wrong with the macro? Oh, shoot. Okay. I know what's going on, and that is annoying. Ah, crapperoni. Oh no. No. I have to put everything in here. No. But I don't. Oh no. Oh no. So the issue is that this format string that is expected should be the last named of this function, right? So it doesn't work that I look up the format message later and then I'm like, oh yeah, just, you know. I really have to provide it here. Which means this one right here is something that has to be called on the outside. Okay, I have to think about what to do then. I thought you could just pass in any format, right? I mean, you could. It's just a warning, right? Right? MSVC, please. What? $5082. What do you mean it doesn't exist? What the shit is this? What? There's 81, not A2. How is it? How? There's C2A2, but that doesn't, like, that's not even remotely close. What the hell? So I think this would just work. It's just warning me that, hey, what you're doing might be slightly unconventional, but duh. I might try and ignore that warning. Oh, we have an ad break going on, so I'll just fix the other errors in the meantime. How about that? Okay, I just fixed two other errors, which basically now calls the right things. So print messages, as opposed to print errors, right? Because it's now all messages we're printing out, not just errors. And right, now I wanted to have a look at lexe.c and see how that stuff is actually used. So we have add token error. And we have add source file error, right? Source file C. Right, those are things that should be fatal. But all of these require file locations. Right, so I should do something for that first. Let's do... Okay, messages, and we basically want just some macros, right? So let's do define add. So we got add source file error. That's a bit odd. But it kind of makes sense. Add source file error. Let's do a type and a code, and then the file pointer, right? And then arguments. And that will call add message, add source file message. And we're basically having type code. Right. Really what we want is statement. And first we need to have a file location. So file location T, location. Actually, let's call this source log, whatever. And that needs the file name, which is file pointer file name. Then we have line. So basically these things, right? Should have left it in there. Wait, do I need to even specify the names? I don't really need to, right? File name, line, column, position. Yeah, okay. Let's just do it this way. Okay. Then we call add message, which will have the type, the code, the address of source log, and then vargs. Right? And then we just close the statement. We need one of these at the end. Okay, my dog just farted so loud. Jesus. Right. I wonder if that macro should even be in here, or rather in here. One second. So cute. She was in really deep sleep. Okay, sorry. I'm gushing over my dog. Okay. Maybe that should be in source file. Because, like, why would I... I mean, I can have this macro in here, I suppose. It doesn't really refer to any other types, right? So... Okay. So then in source file C, all of these need to be replaced with something specific, right? So add source file message. What do we have? We have a message type, which is fatal in this instance, and we now need a message code, right? Did I actually name these like that? Yeah, message code. right, now we need to come up with message codes. Right. So let's just take all the error messages for the source file. So get message for code, right? Let's just do a bunch of these, right? So what do we have? We have invalid UTF-8 byte. Sure. Then truncated UTF-8 sequence. Then invalid UTF-8 continuation. And an invalid code point. Okay. Right, I don't know any good codes for these yet. I mean, we could say source file, right? Or we could say Unicode, right? And then like a message number, whatever. I'm just gonna number these for now. Doesn't really matter. Might want something a bit more descriptive. I don't know yet. But basically, message code 00 is invalid UTF-8 byte, and then we just pass in the byte. And this will actually be fatal, which means it will return. I mean, it won't return. It will exit the process here, right? So no need to worry about any of these things. Similar to here. Don't need that. So this becomes add source file message. Hang on. I forgot to add the file, didn't I? Where am I? There we are. Yeah, file pointer. Okay, I forgot the file. What is the file? Just file. Okay, so here, message type fatal, message code 00, the file, and it doesn't have any arguments after that, so we just do this. Okay. Now here, add source file message. Again, fatal. Maybe I should have macros for like these things. Add fatal message. I don't know. Maybe. Nah, let's not get too far into this. Okay, message code. This will be 2, right? This was 1. I closed the thingy. Great. So that was invalid UTF-8 byte, right? And we provide a byte. This was 01 with nothing. We provide nothing. A2 with something. Okay. File, and it's another byte. And then down here, add source file message, message type fatal, message code 3, file result. Okay, build. That's not a good thing, is it? Keyword gen. I forgot about keyword gen. Damn it. Yes. Oh my. Okay. Message.c and right. So allocate error list arena. The error arena, and then init global message list. I should name this message. Message arena, right? Then we have this. This can, well, it still can happen, so. Okay. Shit. Okay, fine. Oh, yeah, of course. I mean, I didn't add these, right? Duh. Oh my god. Oh my lord, what am I doing? 1, 2, 3, there we go. Okay, what's up now? Case values. Ah, right. Damn. Come on, man. Come on. What are you doing? Too many arguments for function like macro invocation statement. Do you mean like too many? Because it only expects. Yeah, okay. Statement. Okay. What did I do wrong? I thought statement was pretty clear cut. Statement in itself is a macro, I believe. It's in Dani lib base. Statement. There you go. It's this do while thing, right? Oh, do I have to? Right. Do I have to surround this? I forgot how to do this. Like so. Nope. Oh, man. So here's the thing. So the statement thing is just a macro, right? And what it does this do while thingy and places everything on the X in there. So as you can see, like with assert, I have this if right here. So I don't know how to make multi-line things work here. Give me a second, I'll figure it out. So I thought I could just do the braces, right? Because that's essentially like... Really? Okay, let's try a statement, right? So this would be the macro. So what... Okay, what if I call setup console in here? Do you work? So that works. What if I call you in here? Okay, hang on. So this seems to be fine. So why is my macro wrong then? Okay, let's go to the actual file and see how I used it. Because I have type code, file pointer, and then just some arguments. Type code, file pointer, arguments. Okay. Add source file message. Type. Code. File. Arguments. Missing semicolon before while. Oh man, macros get me all the time, honestly. Okay, what if I leave these out? What do you do now? Do you still work? Can you still work? Does that change anything? Just makes it worse. I guess I can just really have one statement with this thing then. Not how I intended it to be, but okay. You know what? Before I like lose my mind on this, let's just do this, right? So we have do. And then okay, do. Then we do this one, while. There we go. Okay, syntax error. I probably forgot something. Let's make sure this is actually okay. Seems to be okay. Okay, what did I forget then? Messages C. No, not messages. Source file C. Okay. Now this is starting to annoy me. Because like that was working fine before. Right. So this part. It basically now complains in this location that I don't pass anything in here, right? So like this. But I didn't think I had to. What if I do it like this? I really don't like this. Yeah, see, it just used to work. So what's different now? Is it really just because of the statement thing? Because I have it in a do while? That would be nuts. Come on, man. Where is error.h? Yeah, so why does this work here? Oh. 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 I passed in the format string as VA args as well. That's why. That's how you make that work. Oh man. Dude, macros. Like, every time. Right, but we do not have a format string. No! Why do you hate me? Okay. All right. This is the moment where I give up. Not like completely. But like give up with the way I wanted to do the API. What I can do is have something like get message format, right? We want the message code. And we have code. That will give us the format. Then we can just say add message. But then the code, do I really need the code attached? I mean, sure, whatever. Doesn't really matter. File location, and then we have format. Yeah. Oh, thanks for the follow. So we kind of split this API a bit. We still need to get the format message, but that will at least make this stuff kind of work. No, it doesn't really, does it? Okay, let's remove the message code. It's okay. It's gonna be 2 calls instead of 1. That's all right. So really get message form. Oh no, then it clashes with this one. So, okay, get message for code. That is okay. Right, and then we have the add message, and then we can say add source file message. Right, we just specify code, the file pointer. No, that doesn't help me either. Ah, no, it will. I at least don't have to do this stuff manually then. Okay, fine. Okay, so add source file message. You're planning on making a compiler, assembler, and linker combo. Nice. Best of luck. So we have the file location. We then add the message like so, and we have the format, which we then just pass in like that. Okay, so this kind of should work. And then on source file, we then just need to say message get message for code, message code. I'm starting to wonder if the macro is even worthwhile then. Because if I'm starting to split this up like this, I might as well just make this a function. Like, you know, like, what are we doing? Yeah. Let's just make this a function. And let's just pass in a VA list. So then we don't need the format thing, right? So this will be a VA list of arguments. And then we have source file t file, and then ... right? Okay, so you never built an assembler and linker, right? I never built a linker either, but assembler is fun. Okay, so then we have the file location. This just turns into file, right? Like so. And then this one here is type, code, source location, and then our arguments. Now the arguments are gonna be this stuff. Right, but for that I need a format. Okay. Right. Okay, did I remove the code from... No, I didn't. So let's put that back. Okay. I'll deal with the implementation of these things in a minute. I really just want to get this right. So, message type, message code, source file, and then whatever I'm going to attach, right? So, for this then, I need the file location, which I have here. I need the format, which is get message for code. Then I have a VA args, right? Just the arguments. I have a VA list, which will be the args with C2C string format. And then VA start, sorry. And this is a VA list. I'm not doing this very often, so okay, and then we just call add message, and I just change the signature to this, right? So to type code file location format args. Okay. So now, implementation-wise, I need... Wait, did I remove the macro? Yes, I did. Okay. Okay. So add message now becomes this one. Okay. So create a new entry, set the type, set the code, set this one. Might actually be able to do something there as well, because we just need the message. No, I still need to do that. Okay. So don't need to get the format like this. I kind of did need to get the format like this. Oh no! Oh god! What have I done? I hate this so much already. Oh good god! No! I just tried to make it easy. No, okay. I'll leave it like this. I think I can do something there. I don't know why I got so worried about... It's just about creating the file location, right? This kind of like annoyed me. But like... Here. Right. Get file location. Like, that's all I have to do, right? And then file pointer, right? Actually, this goes into here, into the source file. Let's just remove this. Go back here. No, that was not the code I was looking for. I had this here, right? So file pointer, and all I want to do with this is basically say strt, no, not strt, I want file location t, and then file pointer, file name, line, column, position. Nope. Right, and then here that's basically all I have to do. Famous last words. Really, we can probably do it like this. Yeah. Whoops. It's supposed to be copy paste, not remove. Okay, and then this will be add message, add message, okay, cool. So that at least, removes the macro woes and like, okay, I need to do one extra call to like create a file location, but whatever. That's just fine. Okay, keyword tokenizer. So we're still in the keyword gen. Because apparently I'm calling add error. Right. Missing separator. And then I return 0. Okay, this is now a bit annoying because now the messages are shared with a different program here, the little keyword generator that I had, which is not really nice. Right. Maybe I shouldn't have shared that, but, well, It is what it is right now. Okay. How many do I have? I have missing separator, missing identifier. 1, 2, 3, 4. Okay. I just give them the code K for like keyword gen, right? But I'm gonna think about like how to handle the keyword gen stuff later on. I mean, keyword gen kind of needs a cleanup. It's like really messy, anyways. It's just awful, really. On all accounts, it's just awful. Okay. Right. How does that work again? Every time. Edits. No. Oh, come on. I forget shortcuts, which is super annoying. Oh, come on, selection. Oh, just Control L, really? No, that was not it. Oh, Control Shift L. There we go. That's what I was looking for. Okay. And then we just need these error messages. So missing separator after enum name. Missing identifier after separator. Missing new line after keyword definition, and then just invalid token. Cool. Okay. And then, so this is based on tokens. But not the kind of tokens that are known throughout the entire program, right? These are just known to keyword definition, which is a bit annoying. But what I then can do is say file location T. Actually, define. We need this one, right? So get file location from source. I just need something get file location from token. Or just get keygen file location, right? And what I need is a file pointer and a definition token. So file pointer and token pointer. Actually, come to think of it, I don't really need to know the token type, right? So what am I doing? So I can just say get location from token, right? File pointer, token pointer. Then we have the file location with the file name, and this one will just be the token pointer. I just need to provide line, column, and position in there, right? So well, that's definitely something that it has, so don't need to worry about that. See, macros are useful. It's just, yeah. So, okay, add message. We have, this is probably just an error message, right? So, message type error. And then we need the message code K0. And then we have get location from token, token. But we have a token pointer, so let's do that. Right? Yes. And we don't have any arguments. Okay. Same here. This one will be K1. No arguments. This one down here will be K2. Arguments and invalid token, which is K3. Okay. Why? Why? What now? Oh, right. Ah, shoot. I also need the file. Cool. Keyword gen C, print errors is undefined. Yes, it is. It is now print messages, right? Okay. Build. Okay, building keyword gen. We still have this stupid argument that is the stupid warning where there's no real documentation for it, which is funny. But let's just try remove this, build, whoa, build. And will you look at that? It prints an error. In the definitions file, line 8, which is correct, column 5, byte 80, error, missing identifier after separator, and it even has error in there, right? So that is cool. Right. So at least that works. But let me disable that warning because that is just nonsense. I mean, I get why they would warn for that, but it's just, I don't know, man. Can these be comma separated, or is this just MSVC WD WD? No, it just needs to be directly followed by the warning. Ah. Okay, this is talking about Visual Studio, but like... Okay, if I do this, what happens? Oh, nope. That doesn't like it at all, so I have to specify them separately like this. Okay. Alright, that gets rid of the warning. Okay, but I want to... C5082. I kind of want to specify what warning messages I'm actually disabling, especially since this one doesn't seem to have any documentation. So instead of then wondering in a few times, you know, in a few months ahead, like, oh, what did I disable there? Let's just, you know, make sure MSVC. This one actually has, what is it? Assignment within conditional expression. Yeah, see, those are some kind of warnings that are just like, hey, it's a basic C feature. Like, shut up. Right. 4706. Okay. Cool, so at least keyword gen is building and running. Okay, and now we can focus on the assembler again, right? This already took way longer than I wanted it to be. Once I fixed all these errors, before I go into the code gen and parsing of the syntax tree stuff, I need a coffee, right? Just gonna let you know, there will be a break. Just a little coffee break. Should take like 5 minutes, something like that. Just wondering when I need to take my dog out. When did I take you out last? Ten? All right. She's good. She's good. You're good. You're good. Unless she still has diarrhea, then I have to like step out for a little bit. But she had a bit of an upset tummy today, so I was actually expecting to be having to take her out for the whole time. But okay, so add source file error. What is this one? This is when we try to read a decimal digit, but we cannot. Now, this is not anything fatal, right? So when a UTF-8 sequence is kind of boggled up, right, then that is definitely fatal. I do not even want to attempt to read anything further because I'm just assuming the file is corrupt and, you know. So we're terminating there. But here, this is just, well, okay, there's some invalid characters in your number, but, you know, whatever, right? We can still pass the rest of the file. So this is nothing fatal. So this should just be an error. Imagine that. So let's group them up a little bit. So this is Unicode, no, source file UTF-8 errors, right? I should probably give them like special codes, but keyword gen Lexa errors. And then we can have Lexa errors. So case, message code, I don't know, L for Lexa, right? Return string literal, sorry, this one. Okay. I still say errors, but it could be any message, right? But whatever. Okay. What? There we go. So add source file message, right? Oh no, it's just add message now. I forgot again. C. But I want get location from source file. Okay. Add message. Now the message type error. Message code is this one. Then we have get location from source file, and then pass in the code point. Okay, add token error. So this is also for decimal numbers if they exceed the maximum allowed values. Okay. Message code L1. Okay, this add token error. So really, message code L1, get location from token, right? And token is already a pointer, and then why is there token length? Oh, because it's a string. Okay, right. Okay. As I'm going through this, I realized, like, maybe I don't like it the way it is right now. But it is like a first step on doing this, right? So Okay, this will be L2. They're all very similar. Hang on, this is source file. I was on the Lexa. Right, this to-do still needs to stay. Whoops, yeah. Add token error. Right, so we can just copy this one essentially. Nope. Which line was it? 324. There we go. So this is also an error. This will be L4, I suppose. No, L3. Yeah, L3. And this just needs token type hexadecimal. You know what? Why don't I just leave these two open, right? Oh my god. Okay. And then the same thing here. That will be L4. But now with a lot more. Okay. Sorry, this is going to be a bit tedious. Add source file error. But you can see some of them have like a bit of a pattern, right? Where you just have to adjust some of the things. For example, instead of binary value, so decimal value or something like that. So maybe I can combine those messages together. But yeah, we'll see about that. So this is get location from source file. All right. again just with a code point, but this will be L5. Okay, let's copy this one. Then 2 add token errors right here. So this will be L6, L7, right? This one will just have binary, and this one has all this shebang. And then we just do case message code L6. Wait, did I just fuck up? No, it was because this was still open. Okay. Whew. Okay. And then missing quotation marks, also a token error, right? So let's just copy this. I know none of these are fatal, so that's at least good. L8, right? Okay. Case message code L8. So read directive. Okay, this one has empty directive and unknown directive. So L9, right? Like so. And then LA. So, okay. L9. And LA. Okay, read identifier doesn't have anything. Read binary shift has token errors. 2 of them. And that's it, I think. Okay. So we just need B and C. Okay. Case and case. Right. Message code L. I don't know. Return string literal and LC. And then we have this one. And we have this one. Okay. Where's like a nice one? This one, okay. LB. And this is LC. Next token type. Okay, and this is the same. Okay, cool. Right. I need to add these to this one. Nine, 8, 7, 6, 5, 4, 3. Okay. Cool. And building and running still works. Okay, well that was the man. Took way too long, honestly. Took way too long. And I'm not sure I'm quite happy with this, but you know, I'm not gonna continue with this. I rather go to more exciting things like parsing the syntax tree, right? But this is similar to what I wanted. So we can have multiple message types. Now, instead of maybe having the type enum, maybe I should just have different functions saying add error, add fatal, add info, right? Maybe that makes more sense. Don't know. The message code, I definitely want to leave like that. Although, you know, I'm not so sure. And also this file location stuff, so it's actually not really file location, is it? It's more like an error location. Or message location. Well, I mean, it is coming from a file, so I guess that makes sense. But yeah, so there's also certain things that can be combined later on, like a lot of these things, like I said, so exceeds maximum value, right? That should be the same error code, because the only thing that really changes is like the formatting. Oh, that is a problem. There's an ad break in progress. I'm sorry. Okay, let me just quickly see if I can do something like, let's put a G in there, right? so this actually works. Now, what about a fatal error, right? Let's put a smiley in there. So at the moment, it won't print any error whatsoever because the smiley is just recognized as an identifier. So if we go to, excuse me, build run, if we just go to line 9, there, it's just an identifier, which is that smiley, right? Let's put that on the first line. Oh, sorry, ad break is over. So I'm just going to test the fatal error. So there's a smiley face right here, right? And at the moment, this smiley face is just being recognized as an identifier. So if I do this, right, you can see here, it actually builds a syntax tree with an expression list, which just has one expression, and the expression is an identifier of this value, which is the smiley face. Yay. Now, but what if this file is kind of corrupt, right? So let's say, can I just drag and drop from here? No, I can't. Okay, fine. So here. I think it's these 4 bytes, right? And then DA is new line. So let's say this one. What if we have that? What was it before? 9.8. So 9.8. And we're going to change it to F8. Right? So now there's some gibberish. And that actually is fatal because it says invalid UTF-8 continuation F8, right? So it expected an UTF-8 continuation character, which this one is not. So we're reporting a fatal error and then immediately terminate. Just exit the process. Okay. Let's... Oh, come on. I hate this tool. Really? You're gonna do me like that? There. Okay, cool. I'm gonna make a coffee. You okay there? I'm gonna make a coffee, and then when I come back, although I almost streamed for 4 hours again. Does it really take that long for the error messages? Damn, man. This was way too long. Git status. Oh my god, I can't type anymore. What? Why did you... Okay, whatever. Okay, build.bat. What did we change? Yes. come on. That was that change, right? This was just the file. I don't know. I don't care about that really. And the rest is probably all just from this, except symbols. Okay. So let's add keyword gen. Let's add this one. Let's add this. Let's add this one. Yep. And then whatever is in base. Okay. Adding new message system. Okay, but also we probably no longer need the errors, so this one can go. Goodbye. And this one can go. Right, can still build, so that's good. Okay. Push. Okay, change the global error list to something better. Well, if it's better, it's debatable, but let's see. The global error list should also allow for other kind of messages, such as infos and warnings. Yes, we have that. Error messages should have the ability to be printed out as they appear or defer to the end if sorted. Allow output messages to be sorted. Well, we don't have done that. Allow output message to make suggestions for typos. Definitely don't have that. Lexa error messages for binary hexadecimal. Okay, yeah, this is still... Well, there's still a lot to do, but I kind of got bored of this, so... Error strings should not be in parsing code. Yeah, we kind of have that. Okay. I should have added a list of tasks instead. Can I change this? Hey, yes, I can. Cool. Oh, you just do it like that. Okay. What? Oh, okay. Cool. So we got that. Fantastic. And that. Oh, god damn it. Cool. Does it actually save the ticks? I'm not sure. It does. Oh, and it also shows 2 out of 6. Oh, nice. Okay, cool. Yeah, kind of new to Gitty, so... I should have done the same here. Well, I also should add a ticket for... Ticket. An issue for the syntax parsing, but... can do that later. Okay. Console age has been modified. Why? No. It should not be modified. Okay, cool. Right, I still have the changes in symbols.h, but I don't care about this one now. No. So next I'm gonna do the parsing stuff. So this means trying to parse the syntax tree and actually making sense out of what we're getting. But I need a coffee. So gonna take a 10-minute break, I think, or something. 5 minutes maybe. Let's say 5. Should be enough time. Okay, see you in 5 minutes. Debuff? Well, you see, debuff is a special kind of debug, which is my way of typing debug with fucking dyslexia. So, really, it should mean debug. So, oh, you know, it's a kind of a debuff because you have to print out all the tabs. Yeah, so essentially we want to get rid of all this code because this was just to see if the syntax tree parsing actually worked. But now we can actually start properly parsing, I suppose. I'll probably only have about an hour, but let's see how far we get. I have to refresh my memory on this stuff. So much happened since then. Oh man. Okay, so we have syntax tree. Syntax tree is expression node root, and that is the expression node for an expression list. That is just a list of expressions. Hey. But this assumes we have skipped all the label definitions in the beginning. Okay, so parser C. Where do we start? I mean, I named it debug parse source file. Parse instruction here. Okay. Get register name might still be useful. Right. Okay, let's do... Nope. Let's get rid of this. This might still be useful. I mean, I just have parse source file. Might as well just name it that, right? That's what we're doing after all. Parse source file. And we do that with a lexer. Okay. There we go. Right. The first thing is we kind of want to get rid of the label definitions first, right? So label definitions are the first thing that fall into the line. I do not want this to be part of the syntax tree because, like, as soon as we find a label definition, we add it to the symbols list. I kind of already had code that does this, right? So you can insert a current label definition, but if I uncomment this, the world will explode because basically this was written before everything changed. Before everything changed. Jesus, I can't talk anymore. Okay. So that is kind of broken. I just left it in here to kind of get an idea of what I need to do. I'm not going to do that. We're not going to bother with label definitions now. I just want to get like basic instructions working. A few of those. Why do I have stats open? Jeez, okay. So let's kind of skip label definitions first. Right? So, how does tree.h. Okay, no. Tree.c. It starts with the current token. Okay, so as soon as we do not have a label definition, we're just gonna start parsing the file, right? So really, we kind of need to be on the Lexa level first and skip a few tokens. So we have Lexa advanced to next line. Or Lexa advance. Okay. Token T. Token is Lexa current token. Oh, I have a get current. Fine. Forgot I added that. Okay, so let's get a pointer to the current token. And then while and just loop as long as we're not like at the end of the file, right? Then if is token end of line, we're just gonna continue. Wait, do I need to do that? I mean, yeah. Then if is token I think label, right? To do add label. White space already gets skipped. And everything else should be okay. I remember the tree is going. Sorry about that. I remember it's just stopping on new line, right? So I have the new line token. So wait, if white space is already removed, I just should loop over the labels, really. But then it becomes an... okay, let me think about this. Lexa advance, Lexa, right? We have a label, we consume that label, we go to the next token. I mean, we need to advance anyways, right? Okay. If okay, let's do it this way. So we loop as long as we do not have reached the end of the file, right? We start out, we check if we find a label. If we have a label, we do whatever we need to do with that label, right? And otherwise, we're checking that we're not at the end of the line, because we still get reported end of line tokens, right? And if we're not at the end of the line, then there supposedly is something on that line, right? Something other than label definitions or, you know, something other than label definitions, really. Let me just see. Yes. So then we can call syntax tree and start parsing, right? So here we're getting the tree. The tree is only for one line, right? I'm doing this line by line. I didn't want to hold on to the whole thing, right? So, and this will give us the tree for the current line. And then we should start. I mean, okay, so this will go on until the very last expression, which will be the new line token, which means this Lex advance. Okay, you're right. Just have to, you know, refresh my memory on this. Really, I should have just looked at what I... Oh, see, get push didn't work. Because I'm always timing out with my session. And then I just have to call it again. So, sorry. Git diff this one. I mean, I already did this here, right? So I can just check. Right, but I didn't skip the... But it does skip the new line character here. Okay, so that was actually... Okay. Good, good. Good, 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 good. Okay, let's just prepare void add label. Do we need the token? We probably need the token, right? Token T token. So this will be our add label. At the moment, there is nothing, right? So to do implement me. Woohoo! Okay. Add label token. Okay. So now tree. really what we want is probably parse syntax tree, right? Do we need the lexer? Probably no longer needed, right? So syntax tree, and then we just call parse syntax tree with our tree. So if there is syntax errors, we still want to continue with that loop, right? Because I want to print out multiple errors for multiple lines. I don't just want to stop after the first error and then stop parsing, because that could get annoying. Okay, so now we have our tree. Our tree always has one root expression node right here. And I forgot how this works. Expression list node. So it actually does create an expression. Okay, it will always create an expression list. Okay. That's what I needed a refresher on. Okay. So we can already make sure that, I mean, it will always be an expression list node, right? So really I can just call get expression list value on the root. So tree root get expression list value for that node, right? And that will give us an expression list t. Expressions. And then we can loop over those expressions. So here we go. So it just has an expression node, right, with some kind of expression in there, or it points to next, right? This is not going to be empty, since, you know, we're already skipping empty lines, unlike the printing that I did before. That didn't care about that kind of stuff, so that's why it printed out a lot of empty expression nodes. But we can at least be sure that there is something in here, right? So I'm not going to be like needing null checks or anything like that. Next could be could be something, or could not be something. You know, it basically means like we have some kind of expression here separated by a white space and then another expression. So this would be next, right? As soon as we have a separator, this counts as one expression, right? Because separators are kind of special. I want to treat them special at least. Okay, and really, so the makeup of assembly is kind of very simple, right? So if you look at the source file, let's skip directives for now, right? But actually, no, let's talk about directives as well. The first thing that you have is some kind of operand, right? No, sorry, not operand, some kind of operation, right? The operation could either be an assembly directive, which means it is an operation that tells the assembler what to do, like instructs, you know, some special instructions basically for the assembler itself, for the program itself. It has nothing to do with the output, right? So for example, let's see alias here, right? This instructs the assembler to give an alias of this name to this number, right? So it then remembers that whenever you use this name, you actually meant this number, like a variable name, for example, right? Alias is not the final final term for this. I'm probably just going to name this constant or whatever. But, you know, or it could be defining a section, stuff like that. The other thing is, if it is not a directive, then it is an actual operation for the assembly language, right? So, it is an actual instruction. Let's put it this way. So it could be LD, CP, JP, or whatever. So we're at least expecting something, right? Either a directive or an instruction. One of those two things. If we do not have one of those two things, that is already an error. That is already a syntax error because, what the hell? Right? So if someone just has like this smiley here, if I uncomment this, right, this is wrong, of course. So really what we're expecting is one of those two things. So I do have some helper methods for this already. I just don't remember all of them. So is node. Okay, by the way, the label definitions I could have also done like this by going through the expression list. But, it's kind of a redundant way of doing it because I'm building a list of all the label definitions. But I can already just do that with the tokens, right? So the tree does buy me nothing here. But for everything else, I kind of want to do it with the tree. So yes, so we have isNode operation, right? So this one right here, and isNode directive. We want either one of those things. So we can just say if isNode operation, and really what we want is the expression node of, just name this list. And this one will be the expression in list expression, right? And then we want to check if this node is an operation, then we do our code for the operation, or if it is a directive, then we do our code for the directive. Now, if we ever reach this point down here, then we already have a syntax error, so we can probably just add that. What do we want to add? Well, this now depends on how detailed you want to be with your errors, right? So you could either just say, hey, I expected a directive or an operation, but it was neither. Or you can be very explicit and actually tell the user like what you found instead. But let this be a problem for later on, right? Report more detailed error. Let's just try and get like something done. So let's go to message, debug messages, message code, missing operation. Right, it's quite a big code, but whatever. So messages, debug errors, case, this one, return string literal, operation or directive missing. Right, and now we can say add message What's it gonna be? Message type error. Message code missing operation, right? And we now need a file location. And I think in my expressions, I should have that. Yes, so an expression node has the column and the position at least. While the syntax tree has the line, right? And then the Lexa has the file name. So this is kind of all over the place. So really probably need to find out something better here. But what we can do is...
I'm here.
No, you're not. What the hell? In case you didn't hear that, Siri just responded. Ah, fantastic. Get token from tree, right? So we have the file pointer. We have the... right. No, this is going to be annoying. Because now I have to remember all of that. Oh, this is so annoying. I should have had more information here. Okay, let's make this a file name, right? Because I really don't want to pass the Lexa around as well. But I mean, I kind of need to anyways. No, I don't. I was thinking because of the arena maybe, but... Yeah, no, let's add that real quick. So results file name equals Lexer file name. Yeah, okay. Fine. Can change this real quick into parse source file. At least it will shut up then. Okay, and then we just have parser C. Fine. Yeah, no, I want a warning there. Okay. I was doing this. Okay, get location from tree. So tree pointer and expression pointer. I don't want to type this out all the time. And then we have file location. This is gonna be tree pointer file name, tree pointer line, then expression pointer column, expression pointer position. Okay. Get location from tree, and what we want is the tree. We want the node. Maybe I should just name this node instead of expression. Right? I mean, they're all called isNode, so let's just call it what it is, right? Yep. And that's it. Token unreferenced formal parameter. Yeah, but that's okay. So build run. Okay, let's see. Okay, we get this for every line now, right? Because of course we haven't validated anything. But let's just see that it's actually just doing this for the right lines, right? So line 12, indeed. So this is the first thing where we have a directive, and it just reports it missing, right? It reports it on column 1, which is correct, because that's where it starts. Now let's see this one, line 28, right? Column 5, so that is at least correct. Okay, and then all the way down. Okay. We could now say else if, really, but I don't think that is necessary. So, I think this is fine. We'll see. Maybe an else if is better, so I don't have to do awkward returns here. Yeah. Else if, else, right? Okay. And then basically we have parse operation, right? And what we want is do I even need the list? It's better to have it this way, right? Let's do directive first. And for the directive, we probably still want the whole syntax tree, which is a tiny bit awkward. And then the expression list. No, you know what? What is a directive? A directive is just a keyword. I don't even think I have to distinguish between directives and operations here, because depending on the keyword, you know, I can do different actions, right? So really, but maybe it's good form to have it separate. And now I'm thinking like, okay, I have the expression list and I kind of need to get to the next thing. So what am I doing then? I could call this again. This will just be inlined anyways. Okay. Okay, so parse directive. And what we pass in is the tree and then our node, right? And then we continue with the parsing code of that. And how do we do this? Well, we know we have a directive, right? So we can call getDirectiveValue for this node. And that will give us the keyword type T. That is the keyword. And then we can have a switch over that keyword, right? And then figure out all the directive keywords that we have. Although at the moment, I have to go to keyword gen. I mean, I have alias, data, and header. But, you know, directives, yeah, I'm not going to worry about those now. Not for now. But basically, this is what you would do, right? You then have a switch over all the keywords and, you know, do something with it. But for now, to do, check directive keywords. And then you would pass the operands based on whatever keyword you have. And then, you know, go through the rest of the expression tree, essentially. If it's none of those, you would report an error, right? So basically do something like this. So what we call that? Unknown directive, right? Although I don't think that can actually be possible. I don't think that can actually happen. I don't think that is possible. Hang on. Directive node. What are you called? No, code to definition. This one. Because we have a token directive. And a token directive is this, right? What? Oh, come on. There you go, we already have an error message, so it can already be a token or it isn't. a directive, I mean. I think I do the same for keywords. Yeah, if the keyword is in the symbol table, I'll just do that. Okay, so this can actually not happen, so we can simplify the parsing code at least. So you will always have a valid keyword in here, right? So this can't really happen. And the same is true for parse operation, right? And we want the syntax tree, the expression node, and then same thing, except this will be the operation value. Okay, so parse operation tree node. Okay, so there's also a special node, is node invalid, right? But that can only happen if, you know, a number parsing went wrong, because then we report an invalid token, which means it will create an invalid node. And if the first node on the syntax tree is invalid, then we still need to report a missing operation. So let's ignore that. Okay. Now, whatever we do after parse operation, maybe I should pass the list instead. I think that makes more sense. Expression list. Right, and then we say list expression. So the reason for this is because this is an expression list, right? So we can have an operation, and then you pass the operation and its operands, right? So this could be valid, but what if, you know, we just have a space here and then some other thing, and another thing, and another thing, and another thing, right? Or what if there is an instruction such as RST, I don't know, whatever, you know, an instruction that just takes one, that doesn't have any operands. What would that be? Oh, come on. Where's the instructions? There you go. Oh, duh, nop. Why did I not think of nop? Okay, let's say, for example, you have nop, right? This is a valid operation, but what if you have another nop, and another nop, and another nop, right? That is invalid assembly syntax. Those should really be going on the new line. So really what you want to do is, after you checked all the keywords and then passed the operands on what you expect from that keyword, you need to make sure that there is nothing else in the list, right? So really whatever this code returns should be the last expression list. And then you just check next to see if there's something else in there, right? So let's make a little to-do in here. To-do implements similar to parse operation, right? So we're going to leave directives all the way to the end. So really what you want to do is check remaining items in the expression list and report an error if there are any, right? So keyword. Let's just do a keyword, right? I mean, we had nop. Why not do nop, right? Yeah, let's do nop. Whoa. That would just be keyword type nop, I believe. Do I have nop? Nop. Ah, no, nop is there. Okay, cool. Yeah. So, in case we have a nop, so there's a bunch of instructions which only have, have no operands, right? So there's a few of them. So we can kind of combine those into the same kind of structure. So really, what we need to do is say list equals parse single operation. And we probably want to give it the tree and the list. Okay. Expression list t parse single operation. Again, a syntax tree and an expression list. Okay. But we know the keyword type already. And one of those keyword types can be associated with like a specific value, right? Sorry. So, for example, oh, dear Lord. Okay, close tabs to the right. Okay, so for example, nop has 0, right? RLCA has 7 as a value, right? RRCA has 0f. Stop has 10. Actually, didn't I used to have a list that kind of... Yeah, there you go. This is actually a sorted list. But yeah, so these are the single byte instructions, right? That the Game Boy supports. So now it's just a matter of writing that into the binary output file and then verifying that it has no operands. So really what we can say is code, right? I'm just trying to like think on how to do this. Sorry, expression list next. What is expression list next? still an expression node. Oh, jeez, I don't like that. Why did I do it that way? I know it's gonna be an expression list. Alright, let me verify that I actually did it that way. Oh. Yeah, it's always going to be an expression list node. Well, or 0, of course, but I unnecessarily overcomplicated my code, but hey, what's news, right? Okay, so this is the point where in the parser, parse operation, we check a specific operation type, right? We call parse single operation and pass in the thing that actually needs to be written into the output file. Now, this is the moment where we need to reference the output file. And I wonder if I even need the syntax tree at this point. I need it for error reporting, right? Hey, chill. No, chill. 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 Chill, dude, chill. Okay, those... She has awoken, ladies and gentlemen. She's barking. Yep. You know what? Let's just add all of these. No, not yet. I don't know what this will be looking like yet. Okay. Focus. I need the output, right? So I have the output binary here. So I need to reference this one. And that happens... And now we could think of a parser structure, right, that holds on to Alexa, maybe also to an arena, and that holds on to the specific output file. So we don't have to pass this like throughout. Maybe that's a good idea. So let's do that. Type def struct parser. Right. Parser. Let's just give it an arena. For good measure, maybe we don't need it. We need the output binary. And we have Alexa attached to that one. I am wondering, why does the Alexa need the arena? Ah. To build the syntax tree. That's how I did it. Okay, fine. Okay, anyways, let's just hold on to the Lexa and the output binary, right? I could... I could actually change this a bit to say... Yeah, why not? The parser could also hold on to the actual syntax tree that it's currently processing, and then I just need to pass the expression nodes down together with the parser. Right. What do we do? We need Alexa, and we need the output binary. Okay. Okay. Parser T. That will be the result. Get memory arena type of the Alexa arena, right? We're just going to put them on the same one. That will be parser T, and then the result will be, Alexa result output current tree return result. Let's call this output. Wanna go back to bed? Okay, there you go. You barked enough? Did you show them who's boss? Excellent. Excellent. Do you want to come over here? Okay. Come here. Come here. On my lap. Why not? Whoa. There you go. Okay. Don't bump the microphone. Come on, lay down so I can type. Yeah, you. Lay down. We're going out in a bit. I promise. Okay, so we have the parser. We can say parse source file like so. That would be the parser lexer. We get the token, token syntax tree. That would be the parser current tree with the parser lexer. And then we call parse syntax tree with parser. Okay. Parser. How often do I need the tree? Just here. Current tree root, right? Just parser t. Same here. Same here. Same here. Okay. Now we just say parser and parser. Get location from parser, right? With this, I also don't need to hold on to this one, right? Because that will be in the lexer. Okay, so let's get rid of that. And then get location from parser. That will be parser pointer lexer file name. Nice. And then parser pointer current tree line, and then we have the expression. Can you stop licking my hand, please? I'm trying to type. How about you lick here? There. It's better. I promise. Tastes way better. No? No, okay, I'm sorry. Okay, get location from parser, and then we have just parser and node. Okay. Okay, so now I have the output. Does it actually make sense? Let's fix stuff before it appears, right? Right, I have forgotten this. Unreferenced stuff. Yeah, warning, warning, warning. Warnings are fine as long as we do not have any errors. It's fine. Incompatible types. Expression node to expression list. Huh? Oh, right, yeah. Okay, now I have the output, and this is just a single byte operation, right? So I can just write it out into the output file. So I'm just going to say parser, and then we have the output, right? And for the output, I have the output binary stuff right here, and this is output binary write byte. where you just pass in the output binary and then the byte you want to write. Now, if the writing fails for whatever reason, that is cause for panic, right? Because we're just writing into an array in memory. That should just work regardless, right? So, but we do not need to worry about that. That will be the responsibility of the output binary to handle this kind of stuff, right? We're just gonna try and write out. We're not even gonna have return codes, anything like that, to verify whether the writing worked or not. Absolutely not the concern of the parser. At all. Zero. Right? So we just pass in the code, and there we go. That's it, right? So that's it, really. But now I said I also need to check remaining items in the expression list, right? And there is some more errors that could happen. So but that is really part of this code right here with the detailed error reporting. So for example, if the node is not an operation and it is not a directive, it could be a separator node, right? A separator node means that we have two expressions separated by a comma, right? So expression 1, comma, expression 2. White spaces don't matter, they can be in there, like, doesn't really matter. Now, expression 1 might still be a valid operation or a directive, but you kind of want to report a special error saying, hey, you have a separator after your operation on directive, which is a syntax error in assembly, right? It goes back again. Okay, there you go. So that is really part of this error code right here. But now it depends where we want to like put so we could either validate in here or do it on the outside. No, I definitely want to do it on the outside. Because I want to do that for all the operations, right? So really for this one, to return an expression list is kind of useless, right? Actually, this whole thing is kind of useless for single operations. Really, the only thing we need is this, right? But if we kind of want to follow a pattern that we can reuse everywhere, it might not be a bad idea to say, okay, I have consumed this thing. So I'm returning you the next item instead. But I don't think that makes any sense in this instance here. So let's keep it simple, right? This is gonna get a lot more complicated anyway soon, so might as well keep it simple now. And then really expression list next, right? And that will be list next. And if next is not null, then we want to report an error. Let's just do this. And this is not going to be missing operation. This is going to be extra stuff after operation, right? Quite a mouthful, but those are like just debug names right now anyways. So we can keep them a bit more verbose. Return string literal. Something is after the operation. Why? Okay, and then build. Warning, warning, warning. Okay, we have an error here. Nope, wrong file. Shoot. Parser. Node undeclared identifier. Yes, that is correct. Okay, unused token. No, actually, let's not get rid of these, but this looks suspicious. Right, this should be list. Okay. Formal parameter with different declaration. Yeah. Parse source file. Parse source file now takes a parser. And then in program, we need to say parser t, parser, and we want the Lexa and the output. Okay. Right. So I just ran it and I just realized, so it always reports that there's something after the operation, right? If the operation is not known. Which is probably not a good idea. No, it should be okay. So what I can do here is also say default and then just add a temporary error message that just says, you know, list expression. Message code unknown operation. I said unknown operations cannot be possible, but I realized, yeah, they can if I, add them in the definitions file. But have not changed the code, then I have added something to the definitions files that it should recognize, but then, the parser doesn't. So it's a rare case, but I mean, it's human error. So ideally, you shouldn't change the definitions file without touching any of these, but you never know. So yeah, let's definitely add that to the messages. What? But did I not save? Oops. Ah, there we go. Yeah, now we'll set unknown operation, but then there's something after the operation Y. It's also not great, but whatever. I mean, I could do a simple return here. That's okay, right? Because we don't care if there's anything after it. If we don't know the operation, then we don't know it. So, okay, so no. So now I can do this for all of these. Funny that no op is not in here. Oh no, it is. I just didn't see it. Okay. But essentially, we're just gonna do this. Oh god. This. And we're gonna do this. Right. This. And what we need is case keyword type. Output binary write bytes, parser, output, and then whatever the code will be, right? And then break. Okay. Nope, we already have in there. Put that up top, whatever. Okay, so DAA is gonna be 0x27. Then we have 0x2f for CPL. Whoa. CFF is 0x3f. SCF is 0x37. Really? Did I kind of... Okay. I mean, we can kind of sort it based on the buy value, but I don't think that matters, to be honest. Whatever. Then we have DI, which is 0xF3. Right. EI, FB, halt, 76, return with interrupt, flag D9, RLCA, 07, RLA is 17, RRCA 0F, RRA is 1F, and stop is, my god, is 0x10. Okay. Now, I'm kind of curious. U8. Oh. unsigned char. But this is gonna be an array of, I don't know, how does array work? View rule. No. 3. No. 3. Oh. I never know how this stuff works, man. I always forget. Come on, what are the rules? Help. F1. Array, no. Oh, wait, there's a little... Ah. Okay, it is array n. So 32. No, this doesn't work. Oh, because right. Array, damn it. Array 32. There we go. Okay. But we're starting at 150, right? So I'm just wondering if we used any of these. Doesn't look like it. Okay, what if I just plant some of these? Right, so any of these. Then we go to the program file. Let's put in that. Control L. Actually, so, and then like so. But this needs to edit, convert case, lowercase. Okay. Now save, run. Wait, you can't omit stuff, right? Wait, multiple rules? Huh, cool, I didn't know that. Well, that's neat. Okay, what is... I don't know my hex. What's 150? 336. And as you can see nothing, which is excellent. Okay. There appears to be an issue in the writing. Fuck's sake. Parse operation. Okay. Output binary. Let's check what we're doing. All right. Run again. Okay, we're trying to write a byte. We want the current section, right? So we have binary, which is split up in sections. We have the current section, which is just the first section. We have a base address of 336, because that's where the section starts. Okay, so far so good. Is output section full? No, it isn't. So we're writing in base position. Oh, I also didn't change the address like a bloody fool. I think that was just the issue, because like that should just work, right? So we just written something successfully in there. So really first buffer base, if we look at this one as an array of like, I don't know, 32. Actually, let's say, let's take the exact value, right? And then go to 336 or something, right? There we go. Okay, now cool. It totally works. Yeah, I totally knew that. It's like, I mean, I never doubted, ever. Okay, again, first buffer, let's say array. This one, we start at 336. Woo! Okay, there we go. First generated code. Woo! Okay, fantastic. Actually, we could now say this is also hex, right? There we go. We should see the exact values as here, like 27, 2F, 00, 3F, 37, F3, FB, 76, D9, 07, and 17, 0F1, F10, 0F1, F10. Cool. Okay. And now you can go over to the more complicated ones, right? So you can have some that require an index, right? So really now you kind of need to start thinking about like little building blocks. And then out of those little building blocks, you then just build the higher level parsing, because indexes also appear here, like for the bit stuff, right? So totally have to be able to read indexes at some point. So let's make something for that. Actually, yeah, okay, I have 14 minutes left, and then I'm gonna call it quits for today. Okay. Do I use bit instructions anywhere here? That would be curious. No, I don't, but that's okay. What am I doing? Damn. Okay, so bit instructions, right? So we want to take a look at these. So we need to be able to parse an index. So really we can say parse index, right? We have a parser and we have an expression list. No, we don't. In this instance, what we have is an expression node. We already know what that node will be, because the higher, so whatever is calling this will already make sure that, you know, it is an actual number, right? So there is a is node immediate, right? And then we can actually figure out, you know, that we need to go in here. So parse index, what we do for that is we're gonna get hang on, bits. They do need indexes in there. Okay, let's do it this way. If node is node immediate, then we kind of want a number. So this is going to be U16. Let's call this value equals get immediate value, right, out of that node. And then we can say if value is bigger than 7, okay. Actually, I might have to, I need to take that call, so I'm gonna call it quits now. But you can kind of see like, okay, now we just have to have like all these little building things for this. And then, okay, I really need to take this. I'm just gonna end the stream, so thanks for watching. See ya.